Hello everyone, this is Miss Long and we are working on section 5.2 using intercepts. And in this unit we're talking about linear equations. So when I'm referring to intercepts, what we're referring to is when you have your coordinate plane and you have your linear equation, the intercepts will be the point at which you cross your x-axis and your y-axis. It's intercepting the axis. So these are very important points because we know if we have 2 points, then we can graph a line. So these are 2 points we can easily grab and graph our linear equation. And mathematically, they have a lot of use behind them. We could interpret them, but we'll do that in a separate video. So first, let's talk about how we solve for. By definition, the x-intercept is where we have a value for x, but y is 0. So if you think about the coordinate plane, we are talking about the point at which we cross the x-axis. So anywhere on this x-axis here, the value of y is going to be 0 because we're not moving up or down. So the coordinate of the point where the graph intersects the x-axis. So then if you think about that fact, the y-axis or the y-intercept is going to be any point at which it intersects the y-axis. So here's our y-axis. And notice I'm not moving left or right on the y-axis. So therefore my x value is 0 and y will have some value. They must always be written as ordered pairs. So when you're writing your intercepts, the x-intercept is going to have some value for x and 0 for y because again we're not moving off that x-axis. And the y-intercept is going to have 0 for x because we're not moving left or right off the y-axis, and it will have some value for y. So how does this happen mathematically? So how do we find the intercepts algebraically? To find our x-intercept, well, first we set up this table. I'm trying to find the x value when y is 0, and then the y value when x is 0. So to find the x-intercept, the first thing I do is substitute 0 for y in the equation. So I would rewrite it as 3x minus 2 times 0 equals 12. I know 2 times 0 is going to be 0, so my equation becomes 3x equals 12. Divide by 3, x equals 4. I'm going to write the intercept as an ordered pair with an x and a y. So the ordered pair for my x-intercept is when x is 4, y is 0. And I repeat the same thing to find my y-intercept. I'm going to substitute 0 in for x this time. So 3 times 0, minus, I'm running out of room here, I'm sorry, 2y equals 12. So I'm just going to bring it up over here to the left. I have negative 2y equals 12. Divide by negative 2, divide by negative 2, cancels. So y equals negative 6. Negative 6. I'm going to write it as an ordered pair. When x is 0, y is negative 6. So that's how I solve it algebraically. Let's take a look at what it is. Let's take a look at a graph and how we would look at this function. Okay, we want to graph using the intercepts in this situation. Remember, to graph a linear equation, you need at least 2 points. So we've been using a table with our 5 values, but now we're going to use 2 points to graph our equation. So I'm going to set up my table with my intercept values, x, y, 0, and 0. And then I'm going to go ahead and start solving. 2x minus 4 times 0 equals 8. 2x equals 8. Divide by 2, divide by 2. X equals 4. So we've got that point. I would write it as 4, 0 for my x-intercept. And then looking ahead at the y, we're going to do 2 times 0 minus 4y equals 8. Minus 4y equals 8. Divide by negative 4. Y equals negative 2. Negative 2. And my ordered pair here is going to be 0, negative 2. To graph that, I need these 2 points, and I know they're both going to be on the axis. So when x is 4, 1, 2, 3, 4, y is 0. Stylus is not working nicely. And the other point is when x is 0, y is negative 2. So we're right down here. And then I'm going to draw my line, arrows on both sides, because I know this is a function and it can go on forever, this linear function. So that's how I would graph this using 2 points, my x and y intercept. And if asked what my y-intercept is, there it is, and my x-intercept, there it is. Let's try one more. Okay, so you're looking at this and thinking, oh no, fractions, they are not bad. We follow the same exact process. X, y, 0 and 0. So I'm going to substitute it in. 2/3 times 0 equals 4 minus 1/2 x. I get 0 on the left side, 4 minus 1/2 x. I'm going to move my constant over. Negative 4 equals negative 1/2 x. Multiply by the reciprocal. These cancel, 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 and I get 8 equals x. Excuse me. So now I'm going to go ahead and repeat for my, when x is 0. So I'm going to have 2/3 y equals 4 minus 1/2 times 0. So 2/3 y equals 4. I'm going to multiply by 3/2, multiply by 3/2. Cancel, cancel. I'm going to cross cancel here. I'm going to go this way. Y equals 6. 6. Let's make sure I did that correctly. And it looks correct. All right, so now what I'm going to do is, I'm going to first write my ordered pairs. So my x-intercept is 8, 0, and my y-intercept is 0, 6. And I'm going to graph my equation, which is going to be when x is 8, and I believe this is a grid up to 10. So I'm right here. And when y is positive 6, so 1, 2, 3, 4, 5, 6. And there we go. There's our beautiful linear function. Okay, so hopefully this has helped you. Again, what you're looking for when you're doing this, your intercepts. So your x-intercept is going to be an ordered pair when y is some value of 0, y is the value of 0, and x is some value. And the y-intercept is going to be when x is 0 and y has some value. And we're just going to solve this by substituting. Once you have your 2 points, you can go ahead and graph your lines and you should be all set. Thank you. Oh, and if you've gotten to the end of this video without saying anything, I would like you to please bring in a canned food to donate. So don't tell people, but if you've seen this video, bring in something we can donate to the food bank. Just walk into the classroom and place it on my desk without saying a word. And that'll be a nice thing to do for the holiday for other folks. Thank you.